In this video, I'm going to talk to you about how to identify functions, if the relationship is a function or not, and then after we decide that, what we're going to do is look at the domain and range of your function. Now, in a previous video, I kind of briefly talked about a function kind of like a vending machine, where what you put in is your domain of your function, what you put in, and the outputs that you get is called your range. And so I talked about putting money into the function and getting out a snack. And what we're going to do is look at functions that have numerical things happening. So you wouldn't be getting out a snack, you would be getting out something in terms of a number. And so the easiest way, in my opinion, for you to write domain would be to just look at your x values. And since we're given points, locating the x value isn't too difficult if you know that your point is always labeled x comma y. And so what I'm going to do is look at all those x values, and my domain, what it's going to do is order them really nicely from least to greatest. So my smallest x value is a -2, then a 0, and then 4, and then 5 in order from smallest to greatest. Now, in case you have a repeating value, so let's say 4 showed up again, in your domain, you don't list it twice. You only list each input one time because it's an input number. Now, the range would be the y values, which would be your output, versus x's are the input. And so what I'm going to do is now look at the y values. And again, I'm going to order them in order from least to greatest. So I have a half, a 2.5, a 6.5, and then another 2.5. But my smallest y value is a half. Then the next y value that repeats, the 2.5, I'll put down, but I'm not going to write it twice in my set of output values because I already know it is a possible output. And then the last output, which is a 6.5. And that would be how you list your domain and range. So x values, your input, and y values, your output. Now, the question up here also says for us to address, is the relationship a function? And how I identify if a function, if the relationship is a function, is look for x values. And if your x values repeat, then it is not a function. So as I'm looking at those x values that I had, none of them repeated, so I would say, yes, this is a function. I notice that there is a repeating y value, but that is not how you identify a function. It is strictly only the x values that you look for. So it doesn't even matter that this repeated because that's not what represents a function. A function would be x values that repeat would make it not a function. If no x values repeat, it is a function. I also have maybe something a little funny for you to remember this. So how I long-term memory remember it is with this funny story that my friend taught me. She said a functioning relationship, you know, like a guy and a girl, or girl and a girl, or a guy and a guy. A functioning relationship would be don't repeat that x. If you broke up for a reason. Don't go back. That's not a functioning relationship. Those people who date and they break up and date and break up and date and break up. It doesn't seem like it's a functioning relationship, and so that's kind of how I remember that. It just kind of always stuck. So I'm not saying that it couldn't be a functioning relationship in real life, but in terms of math, in terms of algebra, if any x value repeats, it is not a function because you're repeating that x. Okay, now I'm going to look at this set of points down here, and I like how this is in a table because it makes it a little bit easier to identify the x's and y's versus in the point you kind of have to know that. Here it's directly labeled. So my domain, which is my x values, I'm going to put in brackets and I'm going to order from smallest to biggest, and I actually notice it already is done for me, so I'm just going to copy that down. So it goes 0 to 8 and it goes by 2s. I already noticed that there are no repeats. So I'm going to right away say, yes, this is a function because none of those numbers repeat. And then my range, which is my outputs, I'm going to list in order from smallest to biggest. And I actually noticed that this also is already written in order, so it's pretty simple. 27 and then 35. Now, my favorite way to identify domain and range is based on points, because then you just list out exactly what those points are. It's pretty simple. But a harder, more challenging domain and range would be when you're given a graph of a picture that's continuous. And so we need a different way to represent domain and range, because there's more than just 1, 2, 3, 4, 5 for x values, because if you notice, this function goes in between 0 and 1 and 1 and 2. So because it's continuous, I'm not going to be able to write it the same way. And so if you have a graph, and if you want to write it continuous, hold on, let me spell this right. Continuous. I hope I spelled that right. Here's how we're going to write our domain. Now, because domain is our x values, I'm going to show you how to write this as an inequality. And how we're going to write it is from left to right. Now, sometimes we will use less than or greater than here, but it will always go in this order, left to right. So domain here of my function, as I'm looking at my x values here, from the center of my picture, which is my vertex here, this arrow implies information to me. And what this arrow is telling me, that my function from here, from the vertex, is not only going up, but it is also getting wider, meaning it is going slowly, but it is going left. And it is implying by this arrow that it is going to keep going left. And then from this point, I also notice that on the way from this vertex, we are traveling also up, but we are also getting wider in this direction, meaning this graph is also continuing to go right. And the left and the right, this part here and this part here, is how we identify domain. So if this graph is going to keep going left, it's going to keep getting negative, 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 negative as it gets wider. So I'm going to put negative infinity, and then, well, my x can't equal infinity, so I'm going to use this symbol. And as this gets wider and wider and wider, this is going to continue to go right, which means infinity here. So that was my domain. Now, the range would be for your output values. And your output values, your y-axis goes up and down, versus your x-axis goes, look at your x-axis here, it goes left and right. So that's why we want to talk about left to right with our domain, but range you want to talk about going low to high here, because your y-axis goes low and it goes high. Now I'm looking at this picture here, and I can tell that there is a low point on the graph. So looking at this point would be the lowest point, and it is 1, negative 3. Now the range, I said it, is the y values. So what y value is the lowest it reaches? I need the negative 3 here. Now this is a point on the graph. That's a closed point. So I'm going to use the equal to line here. And now, how far up does the graph go? Well, remember we labeled this. We said our graph goes up, 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 up. As it's getting wider, it's going to continue to go up. So I'm going to put infinity over here. So I want to give you a couple more examples of this, because domain and range can be a pretty challenging topic. But this video is getting long, so I'm going to stop this one and start a new one.